Hi guys, Libby and I are here presenting your warm-up for the day. And what we're going to talk to you today about is an introduction to Unit 14, which is the mole. And by mole, I don't mean everyday, ordinary, star-nosed mole. I mean a counting number that we use in chemistry to simplify large numbers of particles. So you guys all know that atoms are much too small to see and therefore much too small to measure, right? And so we use a counting number called a mole to simplify these enormous numbers of particles. So in today's warm-up,
Can I write it?
sure. Libby, can you tell me what a pair of shoes would be equal to in numbers?
2.
Yeah.
Because there would be one, it wouldn't be one pair of shoes, it would be 1 shoe, 2 shoes.
Whoops. Can you put 2 on the board there? It's kind of hard.
Yeah.
Okay, perfect. All right, so then if I asked you the question, how many eggs are in a dozen, what would you say?
12.
Okay. All right, so those are just examples of everyday counting numbers.
Like, there's 2 and
Right. And it just makes it easier to say things like 4 dozen eggs rather than count 48 eggs. Now, obviously, eggs aren't atoms, so we're talking about a lot greater number of particles. But before we get into that, let's just kind of look at a question where we rank things, because in this unit, we're going to be doing a lot of ranking and also revisit some ratios. And so in this problem, it asks you to rank the mass of a dozen ants. Are you still listening?
Yeah.
Compared to the mass of a dozen watermelons. So imagine you're at a picnic and you catch like 12 little ants running around.
Yeah.
And you put them on this scale here. Do you think that 12 ants would have more or less mass than if you took 12 watermelons and put them on the scale?
Less math.
Okay, so we're gonna rank that.
Can I write?
I'll go ahead and rank this one because the board's kind of wiggly. So the mass of the ants
Would be
is
less
definitely less than the
the
mass.
of watermelons, because watermelons are big. There's not, like, this is not the actual size of a watermelon because it's not a real watermelon.
Okay, right. But if we measured the mass, it'd be a lot more than the mass of.
Like
12.
1,100.12,000.
That's not even a number, so that's like hugely different. Okay, so obviously we're not going to measure the mass of ants or watermelons at a
Because
picnic
we don't have
because we don't have them. But we can measure the mass of things that we have at home, like water,
and like coffee.
coffee. Well, that mass is going to get to be a lot less here as I drink it. But let's talk about water. And Libby, you're just going to help. You're not going to answer questions to this part because this is a little bit harder, yeah. And so when we talk about water particles are teeny tiny. They are way too small to measure their individual mass. So if I ask the question, how big is one water particle, couldn't measure it, right? But we are able to determine the relative mass of a particle using a unit that you guys probably remember from Unit 3. It's called an AMU. And an AMU is short for atomic mass unit. And so when we first determined the mass of different particles, we used the periodic table. And in the formula H2O, we know that there are 2 hydrogen particles. And each of those has a mass of 1.01 AMU. And we're going to add to that 1 water particle, which has the mass of 16 AMU.
Can I write it?
I'm going to go ahead and write this part. For a combined mass of 18.02, can you write AMU there?
Wait. I need to kind of get in front of what
Yeah, it's a little tricky. And then you'll have to move so they can see the board again. Okay. So AMU, again, atomic mass units are too small to measure. That would be like the mass of one particle of water. So chemists obviously need to use a larger counting number in order to determine mass. A dozen doesn't work because 12 water particles would still be like way too small to see and to measure. 2 dozen wouldn't work.
Wait, what about like 1,000?
1,000 is even too small. So chemists have.
Wait. 1,135,000.
Okay, now she's making up new units of measurement. Okay, so chemists have determined a counting number that we call the mole. And the mole is short for a number of particles that is like way too big to count. So when we talk about a mole is equal to this many particles. This is crazy. And I'll write this out so you guys can see it. Libby, do you have my eraser? Oh, there it is. Hold on.
Wait, can I?
Let me write this number out, and you guys can see how big 1 mole is. I got it. Okay, you hold that. All right. So a guy by the name of Avogadro, you guys remember him? He was Italian. He came up with some
Cool stuff.
cool stuff related to gas chemistry. But he was the first to define 1 mole. And he said that a mole is equal to, watch this number here, 6.022 times 10 to the 23rd particles. So that would be like moving the decimal point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 places. Check out this number, Liv.
Wait, what? Wait, what the heck?
So you said 1,000, but 1 mole is actually equal to 6.022 times 10 to the 23 particles. So again,
Big.
that's a huge number. And I really don't want to count that many particles because that would take a really long
That
time.
would take like 500,000 years.
Yeah, and I don't have that time. Even in a quarantine, there's not enough time to count those particles. So we simplify and we say instead that 1 mole of water
Is equal to.
is equal to 6.023 times 10 to the 23rd particles. And that is equal to the mass, watch this,
Can I write it?
of
Wait, I'm gonna write it.
that much, 18.02 grams. So I already pre-measured
Yeah, it's right
18.02 grams, and if you don't believe me,
there. You can look on
there you can see it. So when we're looking at this amount of water,
my mom did write that.
Yeah.
She already measured it, so.
1 mole of water is equal to 6.023 times 10 to the 23rd. Did I say 322? Sorry. Times 10 to the 23rd particles, which is equal to 18.02 grams of water, which is the volume or number of particles in this little container. So obviously, it's much easier to say 1 mole of water or measure 18.02 grams, which is the equivalent of this many particles, than it is to count the number of particles in that container. So we're going to continue to describe the mole and relate it to different types of elements and compounds in our next video. So signing off for now. Say bye.
Wow.
Wow spells mom backwards, if you didn't know.
Yeah, that is.
Okay.
Because look, but if you write it upside down, it says mommy.
Or Moomy. All right, bye.
I wrote it upside down.